This video is on how calculus relates a little bit to physics. We've learned already that if we take the time derivative of the position time function x of t, we get velocity, vt. So we've been through that already. What that means then, again, we've been through this, if we integrate velocity with respect to time, we get change in position. Well, what's another name for change in position? Displacement. Delta x, if you want to call it that. We've also learned already that if we take the time derivative of the velocity time function, we get acceleration. So if we integrate acceleration with respect to time, we get change in velocity. We've been through those in some detail in previous videos. We're going to run into these next things as this course moves on, but I wanted to just put them out there here at the beginning so that they're there. If we take the time derivative of an energy time or a work time function, what you get is power, some function of time that deals with power. So if you integrate power with respect to time, you get either the change in energy, say the energy that's been transferred, let's say, or the work that was done, depending on what you're talking about with regard to, the situation. Again, we're not going to go into details. We're just pointing out how kind of neat this is. If you differentiate energy time or work time, you can get the power. Therefore, if you integrate the power, then you can get the change in energy or you get the work done. Similarly, if you take the position derivative of a potential energy with position, use of x, or a work position function. Now, just a second ago, we were talking about energy time and work time. Now we're talking energy position and work position. So that's a different sort of a thing. However, if you do that, you're going to get force, the amount of force applied. Now, there might be a negative sign or something that pops into play here, but that's not the point here. If we integrate force with respect to position, we get either the change in potential energy or the work done. And let's finish with this last couple of statements here. If we take the time derivative of the momentum time function, we get force. Wait, I thought if we took the position derivative of potential energy or work, then we get force. Well, that's true. But if you take the time derivative of momentum, you also get force. So if you integrate force with respect to time, you get the change in momentum. One more time, just to kind of point out the nuances here. If we integrate force with respect to position, we get something. If we integrate force with respect to time, we get something different.